Okay, so let's go to question 5. So it's about binomial distributions, and it's a harder problem actually. All right, so you can see that there are a lot of marks here. All right, so for example, like we go to question part A first. So for part A, so the airline sells 74 tickets for this flight. So find the probability that more than 72 passengers arrive to board the flight. That means right now, so the binomial distributions is like so this is just like a scenario in which the aircraft can only accommodate 72 seats, but usually they will just the airline company will just sell extra tickets in order to gain extra money. So and therefore right now the airline company sells 74 tickets. So and therefore right now the binomial distribution should be selling 74 tickets, and then so the probability of arriving is only 0.9. So and therefore this is the binomial random variable. So and then we put x here. Okay, and then in this case it should be x and then greater than 72. So which gives us the answer of 0.00379. Okay, so this is A part. And for B1, so write down the expected number of passengers will arrive to board the flight if 72 tickets are sold. Right now it's not 74 tickets, only 72 tickets are sold. So and therefore it should be 72 plus times the arrival rate, so which is 0.9. So which gives us 64.8. So it's around 65. So this is B1. And for B2, so find the maximum number of tickets that could be sold if the expected number of passengers. So it must be less than or equals to 72. That means the maximum number should be 72 right now, okay? So and then, so we have n multiplied by 0.9, and then the maximum number of passengers who board the flight should be 72. So and therefore this is the maximum number, which is 80, okay? So this is B2. So here comes to the most difficult part. You can see it's 8 marks, right? So and then right now, for each passengers, they will pay for $150 for the tickets. But okay, sometimes if all the passengers arrive, so actually they have to like spending the compensation back to the passengers, like giving the hotel or just like paying for the transportation, something like that. So and therefore altogether, so they have to pay the double of the price, which is $300 for each of the passengers who cannot board the flight. So and therefore the question is asking, what is the extra money that will be increased if we sell 74 tickets rather than 72? So actually if we sell 72, there will be no problem, right? So absolutely we don't have to like pay for the compensations, okay? It won't be like exceed the limit of the boarding passengers. We have 72 seats. But right now, if we sell 74 tickets, then we will have two possibilities that the extra amount that we have to pay. The first one is for the probability of x, which is equal to 73. So of course you calculate it first, all right? So and then if the probability of x equals to 73, actually they have to pay for one more person, right? So for the compensation, because one has arrived, and because they have, the airline company has received 74 people of the price, which is 74 times 150, right? That means the extra 2 people, they have also paid for the ticket. So and therefore, they have to pay for the extra 2 people, but only one has arrived. So and therefore we only compensate for that extra guy who has arrived, but he can't board for the flight, right? So and therefore this is the extra person, the extra cost. All right. But of course, that guy has paid for the ticket. So and therefore, we just need to do the this is the extra cost, which is the addition, and then we subtract it by the extra cost that paid by that extra person, right? But at the same time, because one guy hasn't arrived, so and therefore we have to add back 150. So and therefore this one cancel out. One guy has arrived and one guy didn't arrive, right? So for the second case, x equal to 74. So this time we have to pay both people who have arrived. So and therefore plus 600. Okay. So and then at the same time, because they have both of them has already paid for the ticket. So and therefore this one it should be minus 150 and then minus 150 to lower down the cost. Okay, so this is how we give rise to this answer. Okay, and then this is the expected increase. And for P, for x equals to 74, so the answer here should be binomial PDF 74, 0.9. X value should be 73. So this is 0.00338. And for the next one, binomial PDF again, 74. So the x value should be 74 this time. So this one is 4.11098 times 10 to the power negative 4. Alright, so and then multiplied by 600. So this is the extra costs. And then plus, alright, 300 multiplied by 0.00338. So, and which gives rise to the total cost of $1.260659. And then this one we have to subtract 300. This one cancel out. So and therefore we get the answer should be this one should be the extra cost. So and that's it.